Hi, welcome you all. This video is to understand the concept of finding the number of trailing zeros of a number, like it can be a integer or any other factorial number. So we are going to see three levels of questions which are frequently asked in our competitive exams. So our question is that how many trailing zeros are in the number 30,600? First, we should understand what is trailing zero. A trailing zero is a zero digit in the representation of a number which has no non-zero digits that are less significant than the zero digit. We can simply say that it is a zero digit with no non-zero digits to the right of it. Clearly, 30,600 has two zero digits at the end of the number, so has two trailing zeros totally. But there is also one more zero digit in between 3 and 6. But we should not consider this as trailing zero because after the 0 we have one non-zero digit 6 to the right of it. So we should not consider this as trailing zero. Only two trailing zeros are there. To see the another definition of this trailing zero, 30,600 can be factorized as 306 and 100. Again 306 can be written as 2 into 3 square into 7, 100 as 2 into 5 into 2 into 5. The number of pairs 2 into 5 is 2. So the highest power of 10 it is divisible by is 10 square equal to 100. This is nothing but the actual concept behind this trailing zeros. So our next question is to find the number of trailing zeros for p such that p equal to 1 power 1 into 2 power 2 into 3 power 3 into etc. 50 power 50. To calculate the number of zeros, we need to determine the power of 10 in p. To find the power of 10, we need to find power of 5 and 2. Then we have to multiply them together and find the power of 10. It's enough to find the power of 5 in P because the power of 5 in P less than power of 2 in P. Consider only multiples of 5 in the expression of P. 5 power 5 into 10 power 10 into 15 power 15 etc. 50 power 50. These numbers contains 5. So 5 power 5 into 10 can be written as 5 into 2. So the whole power 10. 15 power 15 can be written as 5 into 3 whole power 15. So like this we write the numbers here. So 50 power 50 can be written as 5 into 5 into 2 whole power 50. So power of to find the power of 5, 5 power 5 contains 5 fives here. So 5 plus 5 into 2 whole power 10 contains 10 times 5 here. So plus 10 plus 15 plus 20 plus 5 into 5 into whole power 25. Here there are two 5's. So one 5 is 25 times there and second 5 is also 25 times here. So let us consider only 125 here. Then add 25 to the our final calculation. So in the last term 5 into 5 into 2 whole power 15. Here also there are two 5's there. So first consider only 150, then consider 50 to the our final calculation. So power of 5 equal to 5 plus 10 plus 15 plus 20 plus etc. up to 50. Take 5 as common. 5 into 1 plus 2 plus 3 plus 4 plus etc. up to 10. So this can be written as 5 into 10 into 11 divided by 2. This is because of the sum of the n natural numbers equal to n into n plus 1 divided by 2. So here we have sum of 10 natural numbers. 10 into 10 plus 1 divided by 2. So 10 into 11 divided by 2. We get 275 here. But we left 25 and 50 times 5 there in the previous slide. So power of 5 equal to 275 plus 25 plus 50, that is equal to 350. This is nothing but number of pairs 2 into 5 350. Or we can say that the highest power of the 10 it is divisible by 10 power 350. So the expression of P has 350 zeros at the end of the number. Next, our final question is to find the number of trailing zeros in 1001 factorial. 1001 factorial can be written as 1001 into 1000 into 999 into etc. 3 into 2 into 1. So the power of 2 in 1001 factorial will obviously be much more than the power of 5. So the power of 10 will be equal to power of 5. So we are using one simple method here. Let's suppose to find the power of a in n factorial, where a is a prime number. Power of a in n factorial is equal to this square bracket means greatest integer function. It gives output of the nearest integer equal to or less than x. So if it is 2.6, then it gives 2. So if it is 3.4 something, it gives 3 only. So greatest integer function of n divided by a plus n divided by a square plus n divided by a cube plus etc. Next, by using this greatest integer function, we write power of 5 in 1001 factorial as 1001 divided by 5 plus 1001 divided by 5 square, that is 25, plus 1001 divided by 5 cube 125 plus 1001 divided by 5 power 4, so 625 plus 1001 divided by 5 power 5, we have 1001 divided by 3125. So if we divide 1001 divided by 3125, we get 0 point something. So the greatest integer is 0 only. So after that, in addition, we get only zeros here. So we stop up to this. We get 200.2 in greatest integer function. 40.04 plus 8.008 plus 1.6016. So by using this function, we get 200 plus 40 plus 80 plus 1 as our greatest integer in this square brackets. So we get 249. The power of 5 in 1001 factorial is actually 249. This is nothing but the number of pairs, so 2 into 5. Or we can say that the highest power of 10, it is divisible by is 10 power 249. So after computing 1001 factorial, we get 249 zeros at the end of this number. Thank you.